Welcome to Maths Classes 7-8 by GK Pillai. This is my first video on the chapter Geometric Twins. This chapter is about congruency of triangles. Previously, congruency of triangles was taught in 9th standard. In this chapter, you will learn the fundamentals of congruency of triangles and how to use the different congruency conditions for doing questions. First, you should understand the fundamentals of congruency, and by repeated practice of many questions only, you will get ready for facing a test or exam in the school. In this video, I have covered the fundamentals of the chapter in full. Answers to some of the textbook questions and extra practice questions will be dealt in my oncoming videos shortly. As I have mentioned earlier, my videos are based on the latest textbooks of NCERT. As a person of long experience, I know very well all the extra questions the students will be taught in the school. My future videos will therefore cover many exam-oriented practice questions from each chapter. My request therefore is to subscribe to my channel and tell your friends also to subscribe and watch my videos regularly. Before learning about the congruency of triangles, you should know what is congruent figures or congruency of figures. Here I have given two triangles. These two are actually congruent only. But how to learn about congruency? The definition goes this way. If figures are exact copies of each other, just like this, or have the same shape and size, they are said to be congruent, and congruent figures can be superimposed exactly one over the other. The meaning of this is, if you take this one and place it over this, that is called superimposition. Then this should exactly coincide with this. Let me repeat this. If figures are exact copies of each other or have the same shape and size, they are said to be congruent. And congruent figures, how you can ensure that two figures are congruent? By superimposing exactly one over the other. Take a trace copy of this, place it over this, both should exactly coincide. Here I have mentioned about this. This is not an important statement. A figure can be rotated or flipped before superimposing it on the other figure while checking the two figures are congruent. Here I am giving an example of how to identify two congruent figures. Here I have given two figures. They look alike. Suppose there are two figures that look identical and we need to confirm that they are congruent. Only their measurements will not be sufficient to verify this. Only the measurements means the lengths. Suppose this length is 2 cm, this is also 2 cm. This is 4 cm, this is also 4 cm. Then you may decide these two to be congruent, but it is not so. Actually speaking, this angle is less than this one. I have extended this line down. So this angle is more than this one. So naturally, if you superimpose this one on the other one, it will not coincide and these two are not congruent. Here, we cannot conclude two figures to be congruent based on their equal arm lengths only. That is what I have given here. The figures may be non-congruent if the angles between the given arm lengths are different. Okay, this is what I have explained here. If the angles are fixed along with the shape and size, the figures will be congruent. Now what you are learning? You are learning the very basic of what is congruent or what are congruent figures. So these two exact figures along with the length of the arms, if you can fix the angles also. For example, if it is 70 degrees, this is also 70 degrees and the arm lengths are same, then definitely these two will be congruent. Now we are going for the congruency of triangles. There are many congruent figures like two circles, two rectangles, two line segments. Suppose there are two line segments with 3 centimeter. They will be congruent unless they have got different thickness. Now, the first one is regarding here we are going to learn the congruency of triangles. The first one is SSS congruency. When two triangles have the same side lengths, then the two triangles are congruent by the SSS congruency condition. Here you can see there are two figures. The sides are same, 3 centimeter, 4 centimeter and 5 centimeter. 3 centimeter, 4 centimeter and 5 centimeter. You can be sure that if you are given the three measurements of two triangles, the same measurements, definitely the two triangles will be congruent. They cannot have a different shape at all. When you constructed the triangles in your previous chapter, you should have understood that concept. The first one is SSS congruency. If the three sides of one triangle are respectively equal to the three sides of another triangle, then the two triangles will be congruent by SSS congruency. The next one is SAS congruency. The condition itself you can understand: side, angle and side. When two sides and the included angle of one triangle are equal to the two sides and the included angle of another triangle, the two triangles are congruent. This is referred to as the SAS, side angle side condition for congruence. So you should be thorough with this statement. Based on this concept only you will be doing the sums. So here, when two sides 4 centimeter and 6 centimeter, here also 4 centimeter and 6 centimeter, and the included angle means the angle which comes in between here. So when two sides and the included angle of one triangle are equal to the two sides, or you can say respectively equal to the two sides and the included angle of another triangle, the two triangles are congruent by SAS congruency condition. So that is what is given here. You must have definitely understood. The next one is ASA congruency, angle side angle. When two angles and the included side of one triangle are equal to the two angles and the included side of another triangle, then the two triangles are congruent by ASA congruency condition. Here you can see there are two angles, 25 degrees and 120 degrees of the triangle. And the side, this is the included side, AB is the included side here, 4 centimeter. The same thing is repeated in this triangle also. 4 centimeter comes in between 25 and 120 degrees. So this is the included side. When two angles and the included side of one triangle are equal to the two angles and the included side of another triangle, then the two triangles are congruent by ASA congruency condition. Now there is one more condition much is not explained. It is not explained that much even in your textbook. This is the AAS condition. You may get sums based on this also. You can say angle, angle, side. Angle, angle, angle and side. So based on this also you will get sums. So this is the AAS condition. This side may be here also. Instead of 5 centimeter, suppose this is given as 7 centimeter. Then this also should be 7 centimeter. You will be able to. So the two triangles are congruent by AAS congruency condition. You may get a sum based on this also. So you should be thorough with this also. So the first one is ASA congruency condition. The two angles and the included side of one triangle must be equal to the two angles and the included side of another triangle respectively. Next is the RHS congruency condition. According to this, when a side and a hypotenuse of a right-angled triangle are equal to a side and the hypotenuse of another right-angled triangle, then the two triangles will be congruent by the RHS congruency condition. Basically, these two are right triangles because 90 degrees each, and the side opposite to 90 degrees, we call it as a hypotenuse. So AC is the hypotenuse of this and PR is the hypotenuse of this triangle. Basically, definitely these two lengths will be more than the other two sides. According to this, when a side and a hypotenuse of a right-angled triangle are equal to a side and the hypotenuse of another right-angled triangle, then the two triangles will be congruent by the RHS congruency condition. Here, it is a right triangle, both are right triangles, and the hypotenuse are given, and one more side is given for both the triangles, 4 centimeter, 4 centimeter. Instead of these two sides, it can be these two sides also. Now the summary, the two triangles, any two triangles will be congruent if any of the following conditions are satisfied. SSS, SAS, ASA, RHS and AAS. These are the conditions according to which two triangles will be congruent. And there is no congruence condition called SSA. Don't think of an SSA condition for congruency. Now, there is a convention to express congruence. You cannot simply say two triangles are congruent. You can name it according to whatever you feel like. Not possible. There is a convention to express congruence of triangles. When two triangles are congruent, they have corresponding vertices, sides and angles which fit exactly over each other. If this is 105 degrees, these two will exactly coincide when you place this over this. These are called corresponding vertices, corresponding sides and corresponding angles. Whenever you prove these two triangles to be congruent, you will prove the same, and ultimately you have to write what are the corresponding vertices, what are the corresponding sides and corresponding angles. I am giving an example here. If triangle ABC is, this is the symbol we use to express one triangle to be congruent to another one. Triangle ABC congruent to triangle XYZ. This is what we say. Then the corresponding vertices are A and X. These are the two corresponding vertices of the two triangles. B and Y, and C and Z. These are the corresponding vertices. In the beginning, they may be the school question paper will ask about this, but ultimately these two are the important things: corresponding sides and the angles. So the corresponding sides are AB and XY, BC and YZ, and AC and xz. These are the corresponding sides of the two congruent triangles, corresponding angles. Here it is just A only, vertices. Here it will be angle A. Angle A is equal to angle X. Angle B is equal to angle Y. And angle C equal to angle Z. This is what you will learn later on. But here corresponding angles are these pairs. All are in pairs only. Now, before going further, you should learn how to prove the different angles of an equilateral triangle is 60 degrees each. You must be knowing by now all the three angles of an equilateral triangle is 60 degrees only each. But this is explained. The way it is given here, I have explained it briefly, but it is explained fully in your textbook. In an equilateral triangle, all the sides are equal. Therefore, let us go further like this. Now in triangle ABC, AB is equal to AC. You must have learned earlier in the chapter triangles. In an isosceles triangle or in a triangle, if two sides are equal, then the angles opposite to them are equal. So if AB is equal to AC, the angles opposite to them are equal. Angle C will be equal to angle B. Angle C is opposite to AB and B is opposite to AC. So these two angles are equal. The reason I have given here. Similarly, AB is equal to side AB is equal to side BC. AB is equal to BC. Again, the opposite angles will be equal. The opposite angles will be C and A. I have marked as 2. From this and this, both are equal to angle C only. Ultimately, all the three will be equal. So from 1 and 2, we get angle A equal to B equal to C. And one more aspect we must be knowing, sum of the three angles in a triangle is 180 degrees. So each angle will be, all the three angles are equal. So naturally each angle will be 180 upon 3, that will be 60 degrees. So ultimately we are getting what is asked, angle A equal to angle B equal to angle C equal to 60 degrees. Now, in this video itself, I am giving one or two basic questions. But almost all the textbook questions and extra practice questions will be dealt in my future videos. In the next video itself, I'll be working out the textbook questions and the answers to textbook questions. Here, how would you check whether two given circles are congruent and rectangles are congruent? This is a textbook question only. Two circles will be congruent if they have equal radii. Suppose there are two circles with radii 7 cm. Definitely the two circles will be congruent. Now rectangles. Two rectangles will be congruent if the lengths and breadths of the two rectangles are equal and the angles between the sides should be right angles. Otherwise it will be a distorted figure. It may not be a rectangle. The length should be the same, breadth also should be the same. Along with that, the angles between the sides should be right angles. All the four angles should be right angles because in a square and rectangle, all the interior angles are equal to 90 degrees each. This is a textbook question only, and this is a very, very important concept. Not only the concept, for practical purposes, this is very important. Unless you are thorough with this one, your answer will be definitely wrong. So be thorough with whatever I am discussing here. Suppose triangle HEN is congruent to triangle BIG. List all the other correct ways of expressing this congruence. That means there are many other different. There are at least three more different ways of expressing the name of these triangles. Here it is given as HEN and BIG. Now the other methods are, first one I have written as it is, and the next one I am going in the opposite way. NEH is congruent to triangle GIB here. The next one I am starting with E. ENH will be congruent to triangle IGB, this one. Then again I am going in the opposite direction here. EHN will be congruent to triangle IBG here. So these three more different ways you can express the name of these two congruent triangles. Now determine whether the given triangles are congruent. If yes, express the congruence. See, these two triangles are congruent by SSS, you can see from the values given: 3.5, 5 centimeter and 6 centimeter, 3.5, 5 centimeter and 6 centimeter. Yes, the two triangles are congruent by SSS congruency. This is the first answer you will write. You may be required to write more. Here only this much. Then you have to write the congruent sides also. Corresponding sides also. See. So for naming this, let us start with R of this triangle. Let us go through 3.5 centimeter and reach E. RE. If you are writing RE for the first triangle, then you should start from J and pass through 3.5 centimeter and reach A. Now it is easy. The next side will be ED only. So you will go from RE to D. The name of the triangle will be RED. The next triangle, you start with J, passing through 3.5 centimeter, A, and again 5 centimeter, same as 5 centimeter here. It will be, you will reach M. So the name of this triangle will be JAM or JAM. So triangle RED will be congruent to triangle JAM by SSS congruency. This is the final thing you should know. Now, this is the end of my present video. As I have already mentioned, the textbook questions will be dealt in the next video itself, and that will be very shortly published. Once again, my request is to subscribe to my channel and tell others also to watch and subscribe to my channel. You can press the like button to show that you like my video.